Good morning or good afternoon, participant, depending on where you are. Apologies for being a bit late. The panel before just ran a bit over. We are still on day 4 of the 36th African Union for Housing Finance Conference. I have the pleasure now, still talking, continuing on the how housing contributes to a sustainable future. We have the pleasure now to introduce Caroline Rey and Tim White from Arup. Caroline is the regional director of the Arup East Africa, and Tim White is an associate in the International Development Department. Arup is a very interesting company doing a lot of innovation and disruption in the sector throughout the world, and we are really looking forward to their presentation, discussing on how is earth construction the way forward for carbon conscious affordable housing. So critical topic for us. And without further ado, I will hand it over to Caroline and Rey. We have 45 minutes. I will be monitoring the chat session, Caroline and Tim, we'll read the question at the end. Perhaps if we can keep 5 to 10 minutes for Q&A at the end of your presentation.
Okay, thank you very much indeed. And good afternoon, good morning to everybody listening in. I hope you can hear me clearly. For some reason, my video is blocked and I can't share video with you, but I'm just going to try and share screen, and then hopefully we can get started on our presentation.
Okay, thank you, Caroline. We can see your screen very well. If you can just put your presentation in full screen, please. Perfect.
That should be there now. Yes.
We see the next slide. That's perfect now. That's perfect.
Okay, that's great, lovely. Yes, good afternoon, good morning. My name is Caroline Rey, and thank you for the introduction, Olivier. I'm speaking to you from Nairobi in Kenya, where I'm based, and I'm the representative for a global consultancy firm called Arup. We are headquartered in the UK, but have offices around the world. We are consultants in the built environment, working in very many aspects of buildings and infrastructure design and implementation, advisory work, and hopefully at times thought leadership in terms of the way the built environment is being rolled out in a global way. I'm joined by my colleague Tim White, who is a structural engineer, same as me, an associate in our international development team based in London. And together we're going to be sharing with you some thoughts to do with the way alternative materials, and we were particularly asked to talk about earth construction, has been considered as a way of trying to meet the housing demand, along with various other alternative technologies, breaking away from the traditional concrete and masonry type of construction that has been used historically. And we want to put that in the context, as this whole conference does, about the SDGs, and to bring to you a case study for a project that we've worked on in Rwanda, where we have used earth construction as a way of, as just one of the ways of trying to align the project towards achievement of the SDGs. Why do we talk about carbon conscious affordable housing? Well, when we think about housing, then very often the SDG that comes to mind, and I'm sure this has been mentioned many times during the conference this week, is SDG 11 with sustainable cities and communities. The one that we would like to mention today is SDG 13, climate action. Because the climate emergency, and I'm sure many of you are very, very familiar with this sort of graph from the IPCC reports, about what we need to do in order to try and get to that maximum of 1.5 degrees in terms of global warming. And that target of trying to reduce greenhouse gas emissions by 45% by 2030, which basically is just around the corner. And then to try and get to net zero by 2050. And so how does that affect our discussion on housing? Well, again, I'm sure many times this week there's the whole demand for housing, and people wouldn't be in this conference if they weren't conscious of that demand for housing. But those of us based in Africa or delivering projects in Africa must also be very conscious of the extent of housing that is specific to Africa over this next period that is so critical in terms of climate change. The graph at the top shows the anticipated population growth by continent. And as we know, the population in Asia, the orange line at the top, is much greater than it is in Africa in terms of total numbers. But the rate of change, the rate of growth there is actually reducing. Whereas in Africa, it is growing. The blue line, as shown below, the rate of growth is much greater in Africa than it is in Asia. So over the period 2020 to 2050, the population growth in Africa will be more than 1 million, whereas significantly less than that in Asia. And so when we get population growth, then clearly that directly correlates to housing demand. And that's the opportunity that we have, both in terms of trying to improve our sustainable cities and communities and improve quality of life for people living in Africa through that, meeting that housing demand. And many of the sessions have talked about, the way financing opportunities and ways of coming up with creative methods of delivering affordability to the population are important. But it's also an opportunity in terms of climate change. The graph on the bottom is just an indication of how much of that how much of that population growth is anticipated to be in urban as opposed to rural areas. And as you can see from the very steep incline of the black line at the top, the vast majority of the population increase that is anticipated will be in urban centres. And that tells us something about our density of housing that will be required in Africa. Because if the population growth was in rural areas, perhaps there would be space for a certain type of housing construction or opportunity. Whereas in urban areas, there is a different form of housing generally needed as a result of the space take for meeting that housing demand. So that's the demand for housing, but how does that relate to those of us that are involved in the financing, the development, the design, the delivery of affordable housing? Well, studies have shown that different sectors of different industries, different sectors contribute different amounts to the CO2 emissions or greenhouse gas emissions. And the construction industry, in terms of what we call embodied carbon, contributes perhaps 11% to the greenhouse gas emissions in any built environment. Operational side of buildings is a greater proportion at 28%. But housing is actually quite low in demand for operational carbon. We tend to have, we have lighting, we have a certain amount of power and a certain amount of energy consumption. And as Danny spoke about in his keynote address at the beginning of this morning's session, introducing passive design measures and other ways of trying to reduce the energy consumption of building will affect that 28%. But in reality, compared with some other types of buildings, perhaps offices, perhaps hospitals, perhaps specific industrial facilities, etc., the operational carbon compared with housing will be higher, whereas in housing our real opportunity to reduce on carbon is actually in what we call the embodied carbon, which comes as a result of the materials that we use and the way we go about building the building. So just to put those two thoughts together in some quotes that we've found here, that population growth, that sort of almost 1 billion people in urban areas and more than 1 billion people in Africa altogether over the next few couple of decades, and also that 11% of emissions associated with the construction or refurbishment of buildings and infrastructure. That makes it really important to do something about it when we're working in our professional capacities as practitioners in one way or the other to do with the affordable housing industry. And just sort of emphasizing again the opportunity that we have as professionals, whether that's finance professionals, development professionals, designers like Tim and myself, compared with the opportunity that we have in our personal lives. Now, I apologize for these slides being related to a UK office, but there are not so many statistics available in Africa at the moment. We're working on it, but not just yet. So I think many of us have been doing a lot less flying this year than we would have done in a normal year because of the COVID pandemic. And so if we were to save on all of our flights, then yeah, we would save a certain amount of CO2. Some people talk about maybe never using private cars. The family car will consume a certain amount or produce a certain amount of carbon. So perhaps we shouldn't be using private cars anymore. Yeah, we can have an impact that way. That's true. There's been a lot of press coverage to do with the food industry and the amount of carbon associated with the production and transport of food. So yeah, we can change the way we eat, our diet, and the way we source our food products, and we can have an impact. But compared with the impact that we can have through the built environment, then actually anything we do at a personal level will be very, very minimal, or at a family level will be very minimal. And so it's really imperative for those of us that are working in the design, the delivery, the financing, the development of any part of the built environment, and obviously housing is our focus this week, in that is likely to have a really significant impact in terms of that global picture for climate change compared with anything done at a personal or perhaps family household level. So why do we talk so much about embodied carbon, and why is it imperative that we think about it at this point in time? So this is a business as usual projection. If we just carry on building as we have done for the last few years, and all of that extra demand for that billion additional people in Africa, if all of that is met through the same way, this is the business as usual projection. So yeah, as the built environment increases, the operational carbon shown in blue will increase. But that embodied carbon, which comes from the process of constructing the building and then what happens to the materials at the end of that process of construction, that's what's going to be the most significant over the next 10 years, which is so crucial in terms of that minus 45% to get to that 1 degree, 1.5 degree in terms of global warming. So what we do over the next 10 years, 2020 to 2030, and in terms of the embodied carbon within our projects, that is going to have a massive impact in terms of the global picture, and certainly the Africa-wide picture in terms of contribution to global warming. So what do we mean by embodied carbon? And I'm sure some of you are familiar with this, but perhaps some are not quite so familiar with the different components which go into what we call embodied carbon. So it's really looking at the whole construction process and the whole life cycle of that building. So in this case, the house. It's the materials which go into the building, where they're sourced from, what those materials are, how those are manufactured and turned into that component for the building construction. It's the construction itself and the energy that is used in that, the way it's done, the transport that's involved in doing that, and the waste it produces. It's also, though, not just at the end of that construction process, it's the maintenance of it as well, because over a lifespan of the building, The maintenance, potentially any repairs, any refurbishment, etc., will also use materials which will contribute to the embodied carbon. And then both at the construction stage and even at the end of life of that particular building type, it's the waste processing, recycling, reuse, recovery of materials, whether you can use waste materials again as part of a new construction process rather than going back to the beginning of the cycle and extracting new materials or producing new materials. Can you go back and skip a stage in terms of embodied carbon due to recycling and reuse? So all of those components together, which will apply to any building type at any stage of its life, they all add up together to what we call the embodied carbon of that building. And we can influence any particular stage of that process. So these are just a few photos of different let me say, what would be termed affordable building or affordable housing types just around my neighbourhood in Nairobi. I'm sure you've got similar views in many of the places that you represent, that you come from. And so whether it's the slightly higher story buildings, whether it's the fairly informal, but in reality it is the affordable housing type made out of metal sheeting, whether it's combined with small retail units, whatever it is, there are so many different building typologies that you sort of think, well, how on earth can we start? Where do you begin in this process of trying to figure out how you influence the embodied carbon of those developments that you might be trying to improve or influence in some way? So I'm going to hand over to Tim, who's going to present a little case study or a little project example of a project that we've worked on together in Rwanda over the last few years, and how we tried to tackle that question of carbon in a very holistic way in relation to the overall objectives for that particular project in relation to the Sustainable Development Goals. So Tim, over to you for a few minutes.
Thanks, Caroline, and hello everyone. As Caroline said, my name is Tim. I think I've been introduced already, and so has the project. So I'll jump straight into it. This is the Rwanda Institute of Conservation Agriculture. It's a agricultural college, and it's conceived to address food insecurity in Rwanda, which is to do with population growth and the climate crisis, which have already been referenced here. I first wanted to give credit to the Howard Buffett Foundation, who are funding the project and who conceived of the idea in the first place, and also Mass Design Group, who are the lead designers in terms of architecture and also parts of the engineering as well. So the goal for this project from the very start was to make it as sustainable in design and in operation as possible. So that meant early conversations about the material choices, wanting them to be as low carbon as possible, starting to think about natural materials that haven't been processed very much. Processing is where you start to add the carbon in, and also wanting them to be locally sourced as far as possible, so to come from the local area and certainly from within Rwanda, and that's kind of in terms of contributing to the local economy. So what we ended up with was foundations that were made of natural stone. The walls are made of earth blocks or rammed earth, and the roof structure are made of timber, and most of the roofs are clay tiles. Next slide, please. So fairly early on, again, we were also talking about the SDGs, and we were mapping the project against them. So we were thinking about the SDGs in terms of what we were designing, so that's sustainable buildings and infrastructure, so all of the water and the energy systems that are present on the site. It's a big site. There's then the broader purpose, of the project. Why are we building these buildings? And that's to do with sustainable agriculture. And then finally, there was how we were going about delivering it. And that's that talks to SDG 17, and that's kind of this idea that it was very much a collaboration between the UK and Rwanda, and there was knowledge transfer happening in both directions through that collaboration. So yeah, the sustainable buildings and infrastructure, that's talking about water, energy, the materials that were used, and so on. And the college itself is an educational institution, so that's clearly going to contribute to SDG 4. It's also about food security, so that's SDG 2. So those are the kind of the primary contributions that the campus will make once it's up and running. And then there's the whole series of secondary contributions as well. And I think overall we mapped it against 15 SDGs and I think something like 41 targets, and it just goes to highlight the interconnectedness of the different goals, I think. Next slide, please. So once we decided that we wanted to use earth construction, the next step was to start understanding the soil that was on the site. The idea was to use the site soil given the size of the site. So first of all, you test the soil itself, and there's a whole series of tests you can do to understand what sort of soil you have. Once you understand that, you can then start making some test blocks, which you can see here on the left-hand side. So each one of those test blocks has a different mix in it. And once you've made those, you can then start testing the blocks themselves to see what results you're getting and to check that they're going to align with the local regulations and specification and all the rest of it. Once the project was up and running, you can see here on the right-hand side, this photo is of the production facility where the blocks were being made by hand. It's quite labor intensive, so it's good for creating jobs. And you can see the scale of what was happening in terms of all those packs in the background are piles of blocks that have been covered in plastic sheeting and they're now curing. So each step in the process, from testing the soil through to compressing the block in one of these presses, that all needs to be quality assured. And often if that process is unfamiliar to the workers who are working on it, then you're going to need to provide training. Next slide, please. So this was to highlight that it wasn't just about the walls that were contributing to the low embodied carbon of the project. There was also this decision to use rubble stone in the foundation. So commonly people would use concrete, which obviously has lots of cement in it and all the rest of it. We chose rubble stone, which was available locally. It's quite a labor intensive way of building, so it was good for creating jobs, as you can see here on the site. And the picture on the right hand side is showing a bit of the kind of the standard detailing that was implemented for the earth walls in terms of ensuring their durability. So you can see that there's a roof overhang to protect the tops of the walls. You can't see so well, but there's a plinth at the bottom and the walls are raised above the ground, so that protects them from any water that's at ground level. And you can also render the walls, of course, as well to provide a bit of added protection. So the detailing and the durability does need to be considered in the architecture. Next slide, please. So when you're building with earth, it's unlikely that you can escape the use of cement. So another way to ensure the durability of your earth blocks is to add some cement into them, and that can improve the strength and the water resistance of your blocks. Here they were using a mixture of ordinary cement and also something called pozzolana. Pozzolana is basically a low carbon cement, and you can use it up to 30% by mix with the ordinary cement, and it's actually cheaper than ordinary cement, and it has an awful lot less carbon in it. So this is a very simple decision that can just serve to cut a big chunk of the carbon out of your project. And that's not just for making earth blocks, that's for your render, for your mortars. If you're making concrete for beams or things like that, then it applies to that as well. So this is a very effective way to reduce carbon. And Pozzolana is available in East Africa. It's the kind of go-to low carbon cement, I would say. Next slide, please. So this then is one of the finished houses. This is the result. I think it serves to show that earth can be an aspirational material as well. You can see that a very kind of high quality finish has been achieved. It's also got very low embodied carbon. This is about 200 kilograms per meter squared, and that's about half of an average educational building, which is what this was compared to, given that it's a college. 96% of these materials came from the local area, and 900 jobs were created on site. The vast majority came from the immediate district that the project was being built in, and about 300 of those were given specialist training in one trade or another. So overall, the project was contributing positively to society and also to the environment. Next slide, please. So then, before I hand back over to Caroline, just wanted to finish on this diagram here, which is a whole life carbon assessment for the built environment. It's been developed by the Royal Institute of Chartered Surveyors, and it sets out how we can measure carbon in buildings and so on. So this is the use of carbon factors, and for the life cycle of a building, you can break it down into 4 main stages. So this first one that's highlighted in that kind of orangey color on the left is to do with the materials themselves. So you've got the raw material, how much carbon does that have in it? You've got some extraction and then transport to perhaps another factory where it might be processed, and then you've got more carbon to do with that process. So the less processing you do, the less carbon you have in your materials, which is why earth and stone and things like that have much less carbon. Next slide, please. The next stage is kind of transporting it to site and actually constructing the building. And by the end of that, you will have got a finished building. These steps tend to be a lesser contribution than the previous one. Next slide, please. So then we've actually grouped all of these final 3 steps together, and this is kind of what happens after you finish the building. And so for designers, we tend to have less control over these steps. For developers, for building, this is an area where you do have more direct control over, and it can actually really have a huge impact on the calculation. For example, if you were to decide that a building is no longer useful and to demolish it and then to rebuild another one, and if you did that after only 10 years, then of course your embodied carbon has just doubled or more. Whereas if a building stays in useful service for 100 or let's say 100 years, then obviously that's done very, very well, and the carbon footprint as a result is much lower. So all these questions about, are we going to reuse buildings? Are we going to reuse materials? Are they flexible for the future? These are all important questions, but they're also quite thorny questions that are quite hard to answer, especially at the very start of a project. That's it. Thanks, Caroline.
Thank you, Tim. Again, just to go back to something that Dennis said in his keynote speech this morning, the opportunity for influence and the cost of that influence is much easier at the beginning of the project. So when we were talking about the cost of introducing green building measures, if those decisions are made very early in the process, then the cost, the extra over cost is very low. So the same applies to the opportunity to influence whole life cycle carbon. when you're working at the end of life or handover and closeout at the very end of construction, and you're trying to influence carbon, then actually it's very difficult because the trajectory has already been set, and it's very difficult to make those changes. It would be very costly to make those changes. But if you're involved at perhaps the strategy to do with that housing portfolio, the brief, the very early concepts of that, the whole definition of the project, the opportunity and the cost for carbon reduction will actually be less, because that early decision making allows you to make that same change at a much lower cost. And so I don't know from the people listening today, you know, how many are involved in, you know, perhaps construction and commissioning or design or definition, but I suspect that many will be involved in that early thinking about projects, the briefing stage, the early concepts, even the whole strategy about how to go about doing the project. And so I would just appeal to those who are listening, who are involved in those first stages of the project on the left-hand side, to really start thinking about the opportunity to influence whole life cycle carbon, in addition to trying to meet that pure housing demand at an affordable level. How do we go about trying to do that? Well, it's to think about the questions, and this is just a diagram that we use as designers, but I think it applies to other professionals involved in the delivery of construction as well. Is build nothing the answer? Well, perhaps for the housing question with the population increase, that's not necessarily possible, but perhaps new construction can be looked at in a different way. Are there opportunities to refurbish or to repurpose existing buildings in any of the context in which we work? Building less, so both in terms of reuse of existing buildings, or potentially just looking at unit sizes, and obviously that has an impact on affordability as well. Building clever, so yes, this is where some of the low carbon materials and potentially earth or the cement, the type of cement, comes into play. But also thinking about finishes, thinking about every aspect of that construction that's being done. What about building efficiently? Just trying to make sure that there isn't over-design. I'm not suggesting that we should under-design things, but in terms of over-design, sometimes people who are worried about quality control on site will throw extra material at the construction because they know that the accuracy in construction might be wanting. Is there a way that we can improve our construction supervision, for instance, and the level of monitoring that's needed so that we can actually minimize the amount of materials that are used and we actually build more efficiently, which will have a positive impact on the carbon content? And certainly minimizing waste, incentivizing a careful use of materials on site, and minimizing waste will certainly have an impact as well. And how do we go about quantifying that? Well, there are methods of doing that, and this is a publication that's UK-based from the Institution of Structural Engineers that our company has helped write or contribute to. There are methods of trying to calculate embodied carbon, and the data involved in that in order to try and get this accurate for Africa is still a little bit in progress. Tim and I are involved with others in terms of trying to actually get more accurate data for projects and for materials in Africa, so that more accurate quantification of embodied carbon can take place. But the idea is to work towards rating systems. These sorts of diagrams have become very, very familiar to us when we buy electrical goods, you know, a refrigerator or a microwave or something like that. So why can't we have the same thing for buildings? That we actually try and progress towards the green, the A plus for our buildings as well. Now, the data exists for this to be done in certain countries, including the UK at the moment. It doesn't, you know, completely exist at the moment for Africa, but the thought process that we've been talking about today That can be adopted at any time, even if the data is still in development to get accurate quantification. The relative quantities and the relative impacts of different design choices and construction choices can still be quantified to give some sort of rating at the moment. And I know IFC Edge that Dennis was talking about earlier, that touches on that, but I think it's imperative for us to get into greater detail, greater depth to think about the embodied carbon in addition to the operational carbon of our housing infrastructure. So just a little reminder about the opportunity that we have for impact. Going back to the same statistics that we showed earlier in terms of the opportunity that the built environment has compared with what we have as at a personal level or perhaps at a household family level. There is actually a huge significance in what we do in terms of our choices and the influence that we exert as professionals who are working in some way or another in the built environment. That is so much more impactful, both in terms of the broad SDGs, but also in terms of, you know, this embodied carbon reduction. So just touching finally on a few specifics, of what we can do. Well, perhaps at that project briefing stage, it's just trying to make sure that there is a conversation about carbon, to actually ask for carbon information to do with the projects that we're conceiving, or perhaps that we're financing or planning to finance. Can we make climate-informed decisions to do with those projects? Then on the specific project or portfolio of projects that we're looking at, what are the opportunities? What are the broad SDG opportunities in addition to carbon? Tim showed the ones that we looked at for the project in Rwanda, to do with education, to do with partnership, to do with education, to do with training, to do with labour and local skills being employed. It's not just about the materials, although clearly in terms of embodied carbon, that's a very big component of it. And although there is uncertainty in terms of quantification of data in Africa at the moment, although work in progress, but there is uncertainty at the moment. I can't calculate things, I can't define things precisely at the moment because we don't have adequate data. Well, don't let that stop us doing something, because doing something is better than doing nothing. In terms of how the project is delivered, you know, what about the supply chain? Can we actually work with the local supply chain? I know some of the other speakers have been speaking of that in relation to how in their local environments for their projects, working with the supply chain, working with trying to get local manufacture of materials. Tim mentioned it in relation to local labour being employed to manufacture the brick products that were going to be used on site. Think about transport. How can we incentivize better practice? It may not be best practice, but can it be better practice than business as usual? How can we incentivize that? And what about project completion? Yeah, sometimes it's difficult to influence what happens at the end of the project, particularly if it ends up by being an owner-occupier housing unit. But when we're involved in building things, or in terms of supporting the construction of things, what is the design life of that building? Do we expect it just to? Are we only interested in it lasting for, you know, maybe 10 years or something? What is our outlook in terms of the quality of the product and the lifespan of that built environment infrastructure? Because the housing demand will be there into the future, but will our buildings be? And how can we incentivize, or how can we create a feedback loop so that we learn from projects that we do in 2020 and make sure that in 2025 or in 2030 or in 2035, those projects that we're still promoting, financing, supporting in some way are better than the ones that we've done this year, next year, 2021. Those of us that are involved in sort of portfolio delivery can really think carefully about those feedback loops, so that even if data isn't perfect and the opportunity for quantification of the benefits of our projects isn't perfect now, we can still start trying to estimate our baseline and create a feedback loop so that in 5 years, 10 years, we are doing things better than we have been today. And is earth construction part of that story? Yes, it might be. It might well be. And there are many examples, in addition to the ones we've been talking about today, of how earth construction could be very appropriate, very affordable, very appropriate for a low density type of housing construction. And the presentation that we heard earlier today to do with the Sri Lanka projects is perhaps another example of where that has been used. Cement stabilized earth blocks were used to positive effect in that context. But earth construction won't solve all of the housing crisis that's coming in Africa, or that we have now and is still to come, because of that urban population growth that we mentioned earlier. That urban population growth implies a density that cannot be met by earth construction, because you simply won't be building the high-rise buildings in earth blocks. The material is simply not appropriate for that use. And that's where Tim's story about all of the materials, every component of the building that we think about, needs to be really important, because this whole principle of trying to impact SDG 13 and climate action through the way we develop the built environment applies to every single project, not just to earth construction. I think we are probably just about out of time, so we'll leave it there. And yeah, I'm not sure if there are any questions, or if there are it's time for questions.
Thank you very much, Caroline, and thank you very much, Tim, for an excellent presentation. We do have a few questions. Some have been addressed already we received them while you were presenting, but I think have been addressed by your presentation. But I'm still going to read some that I think are still outstanding. Sita is asking, could you describe the uptake of Povolana in East Africa? Do you think the market is ready to embrace it, or is it just aware of it?
Sorry, could you say again? Is Africa ready to embrace
the uptake of the project in East Africa? And do you think do you see any appetite for it? That's
for earth construction, or for the discussion about embodied carbon? I wasn't clear.
The earth construction.
Earth construction. That's an interesting question, because it is to do with the perception of earth as being an old-fashioned traditional material. And I think one of the things that we and Mass Design Group, who are the lead designers and architects for the Rwanda project, one of the things that they were trying to demonstrate there is that it can be a very high quality aspirational building or material. So the photo that we are seeing here with the students in a discussion group with a rammed earth wall in the background, yeah, it's different to, you know, a smooth shiny plastered finish, you know, painted in white or whatever. It's very different. But those spaces, those teaching spaces, and even in the accommodation, the student housing that we showed a photo of earlier, they are high quality environments. And so used in an appropriate way, you can create this very, very good quality environment. Clearly very good in terms of passive design. The thermal characteristics of it will be very good in terms of a warmer environment, etc., etc. So it can be used for high quality construction, but that does require a careful quality control on site, and very careful detailing during design, and very careful application of all of the principles that Tim was talking about in his presentation. So will it be appropriate in every context, even when the structural capacity for low rise is adequate? No, it won't be. It won't be. It will be seen by some as a retrospective move, but at the same time, it's something which can be considered as a portfolio of different materials to use in trying to meet the housing demand.
Thank you, Caroline. Thank you very much. I'm just going to read one more question because time is running out, unfortunately. But please, there's a lot of appetite and interest for what you are doing in your project on the continent. So if you can spend some time after in the chat section engaging with our participants, that will be really appreciated.
Sure,
Thank you so
no
much.
problem.
So the last question, I think, is for Tim from Enrico. What kind of finishing did you apply over the Hearst block? Does that involve higher maintenance during the building lifespan? And beside the embodied carbon comparison, did you investigate the price comparison with standard locally available concrete block? And what is the price increase?
Tim, would you be able to answer that?
So yeah, the first question on finishes, it was often with the render or the plaster, it's a bit of a experiment. The key thing to remember is that you want a plaster that's compatible with your wall. And this is about how breathable it is, and it's about how much cement you're putting in it. So you want a similar amount of cement in your wall as you do in your plaster, so the two are compatible. The more cement you put in there, the more it kind of becomes like a very weak concrete, and so you might get better durability over time, but you're going to increase the carbon and you're going to increase the cost a lot. And it, as I said, it's like a weak concrete, and it's not a particularly effective way to make a weak concrete like that. But throughout history, people have experimented with all sorts of things in render. People might add straw, or you can add bitumen, or all sorts of different things. In terms of the cost comparison, so I think this certainly was done at the start of the project, and a key initial question is your soil suitable for making good blocks? So if you've got good soil, then you can add a relatively small amount of cement and you can get a good block, and through that process you will create a block that is certainly cost competitive compared to a concrete block, or compared to a fired brick or something like that. The more cement as I've already said, the more cement you have to add in, if you've got a poor soil, then the more expensive it becomes, and it might become less competitive. The thing you need to remember is that if you're doing it yourself on site, then you will also need to factor in some training for the workers. So if you've got a big project like we had in Rwanda, then there's an economy of scale, and you're training up a group of workers, and then they just keep producing block after block after block. If it's a very small project, then that might become a bigger part of your overall budget.
Thank you, Tim. But thank you again, Caroline and Tim, for an excellent presentation, very informative. Like I said, there is a lot of appetite to discuss further with you from the participants, so please take some time to engage with them. We are now at the end of this session. We have 2 sessions running in parallel in the session tab, so I invite you to log in, and we're looking forward to engaging with all of you just now. Thanks again very much, and have a good day.
Okay,
Thank
thank
you.
you.
Thank you, Caroline.
Bye-bye.
Thank you, Tim. Bye-bye.